Today we're going to talk about mechanisms and simple machines. This main section is on levers, wheel, and axle and pulley. We'll get to those in a later video. Today we're just going to kind of discuss mechanical advantage, what it is, and kind of the work that's done upon those different objects in that simple machine itself. There are 6 different types of simple machines. There's the lever, there's a wheel and axle and a pulley, and there's also an inclined plane, a wedge, and then a screw itself. Each one of these simple machines applies and has a mechanical advantage, the reason why we use them and what they kind of do inside of a system. Mechanical advantage itself is either a ratio of our forces or a ratio of the distances that's there. So the ratio of the magnitude of the forces, how much force is being applied, so 10 pounds, 5 pounds, 20 pounds, 100 pounds, and then the distances, 5 inches, 10 inches, 20 inches, 30 feet, 50 yards, whatever we're looking at with that. And we use all of those different ratios to kind of figure out how well a machine works and what we can do to edit and change it to get to what we're trying to accomplish completed. So mechanical advantage, for example, kind of look at it. Mechanical advantage is 4 to 1. What does that tell us about this mechanism or simple machine? Well, it tells us something about the forces. What it shows us here is that the force to lift this and push this box up this hill is 4 times less than the force it takes to lift this box completely straight up on that hill itself. So it takes less force to be able to move it up if we push that across. But what does it tell us about the distance? Well, it then tells us then that that distance here is 4 times bigger than that distance of that straight up and down there. So it takes less force, but it takes a greater distance to be able to work with. And force and distance then is talking about work. The work is the force applied to an object times the distance that travels. So in order to move that box on the previous slide, we still needed the same amount of work, whichever direction we took it, but it just meant what's our ratio of force to distance that we wanted to travel. So that work itself is that force times that parallel distance. So, work, we have the force times that distance, times that force, times that distance. Both of those have the same amount of work to get those blocks, or those 2 blocks, right to that top of that ramp type of that location. So both those examples present us something different. So it has a magical number with it, which we talk about as mechanical advantage. Mechanical advantage greater than 1, which means it takes less effort force to overcome the resistance force. So that hill was a perfect example. It took less effort to overcome that force of that block to go and move it. Another example of mechanical advantage greater than 1 is a wheelbarrow. Wheelbarrow, you put 200 pounds of concrete in the wheelbarrow, and then you're able to lift up at the end of it by using maybe only 100 pounds of force, and you can actually go and move that. So you can move objects around that you couldn't without using that simple machine. The thing is, it takes a greater distance. So back to the wheelbarrow example, from that wheel, it's a fulcrum, to the load, or the concrete, that has a shorter distance than the wheel to where your hands are on that. So, if your hands are further away from the fulcrum, it takes even less force. The closer your hands are to the actual resistance, that concrete in the middle, takes you more force to work with. And that's what we'll kind of discuss here in the next couple of slides and presentations. You can also have mechanical advantage less than 1. Mechanical advantage less than 1 means it takes more force to overcome that resistance force, but less distance. Example of mechanical advantage less than 1 would be tweezers or chopsticks. Or if you got a set of tweezers, you've got the fulcrum at the end where the things are connected. You've got the force you apply in the middle, and then you have the little splinter you're trying to get out of, like your thumb. So you can squeeze in the middle of those tweezers, but you won't really kind of hurt your thumb. You're just trying to pick up that little piece. So your force that you're applying to that is greater than the force that you're trying to pick up with, or at the end of it there. Think of chopsticks as you're trying to pick up your food. You're squeezing in the middle to try to get that right. You feel like you're really trying to squeeze it to get it work, but your food is never really smashing. If you took that food and put it in your hand, you'd smash it with that same amount of force, but it stays together because of that mechanical advantage being less than 1. So one thing we got to know, mechanical advantage is never less than or equal to 0. So if we get something less than or equal to 0 in our calculations, we know we did something wrong. We go back and try to fix that. So we've got ideal mechanical advantage. Our ideal mechanical advantage is theory-based. So we're not talking about friction being lost when we try to move something. We're just looking at the distances traveled. So whenever we see something and we have two distances, we think IMA. And all we've got to do is take the distance to an effort and the distance to that resistance and divide those two. So it could be distance from a fulcrum, it could be distance from whatever we're looking at, but we'll have one piece, we're looking at our two distances, we're able to divide those, calculate ideal mechanical advantage. If we're ever given or we have two forces and looking for mechanical advantage, we're going to solve for actual mechanical advantage. So actual mechanical advantage means we're thinking about the friction. There's a little bit of friction loss that's taken into consideration when we're trying to actually apply forces on things. So we're looking at the force magnitude. So I have force of resistance, force of effort. So if I'm trying to lift that 200 pounds of concrete, that's my resistance. I can apply 100 pounds of effort to be able to lift that. That means I've got 200 divided by 100. I've got an actual mechanical advantage of 2. So whenever I have forces and I need a mechanical advantage, I go ahead and solve for that actual mechanical advantage. So those are kind of just examples, kind of key terms that will bring us forward as we go and look at different types of simple machines and what they do for us.